Alright guys, it's Z-axis build day. I'm super stoked about this part of the build. Let's head out to the garage and get all the parts we need. Ooh, look at all the Z-axis parts. Okay, quick part rundown. We've got our main structure for the Z-axis. We've got our stepper motor and mount. We've got a shaft, 11mm stainless steel shaft that came out of a salvaged printer that we'll use as our main rails for the Z-axis, and our shaft mounts right here that are 3D printed. We've got our wheel and guide wheel assembly to allow the Z-axis gantry to roll along the horizontal member in the Y direction up here. We've got our Acme threaded rod with our threaded coupler right there. We've got our lead screw nut, which will mount to our linear bearings that I designed and 3D printed right here. This piece right here will slide up and down these rails. This is our main Z-axis carriage, which will hold the tool. In this case, we're going to use a Dremel Multipro 395. And I found the mount on Thingiverse. These screws or these bolts right here are going to be the axles for our wheels that allow it to roll along the T-slot, and this panel right here will tie those bolts together to make sure that they stay parallel. You can also see I've included all the other tooling. Any questions? Let's get going. Okay, the first step is we're going to take our main bracket here that's already been pre-drilled, and we're going to add our motor and motor mount to the bracket using 4 1/4-20 screws. Okay, now we need to add the linear bearing to the tool head assembly. You can see I already have this pre-assembled using a part from Thingiverse, and I'll include the link below. So using just a couple 1/4-20 machine screws with a tapered head, we'll add this to the assembly. Okay, now we're going to add our lead screw nut. One of the things you'll notice is that I had to do some modification to that lead screw nut. I had to cut off one side of it and I had to do some file work. One of the things I'd probably do differently, if you notice I've got a lead screw hole right between the two shafts. If I were to do this project again, I would probably offset that lead screw a little bit from these shafts so I have more room for hardware like the lead screw nut. Alright, now we add our lead screw. Okay, now we're going to assemble our rail system, and we've got 2 brackets and our 2 stainless steel rods. The 2 brackets, you'll notice, are slightly different. The bottom one has smaller holes for the shaft than the top one, and the reason for this is because the shaft that we got out of a salvaged printer, and it has these recesses on the ends. Instead of cutting those off, we're going to take advantage of those and allow for a little bit of a step in the bottom bracket so that if the screws become loose or if the rods become loose in the bracket, they won't slide through. First we'll slide the rods into our top bracket. got the rail assembly fully assembled now, but one thing that we haven't done yet is tightened the screws onto the shafts, and there's a reason behind that. We want to make sure that when we mount this to the main bracket that there's no binding, and we want it to settle nice and tight. Before we add our main Z-axis assembly, we want to add our axles for the wheel system that'll allow this to move in the Y direction. Okay, add the coupler to the threaded rod, another link that I'll include below to the Thingiverse part. And now we're going to take the bracket assembly that we assembled earlier and slide the main Z-axis assembly right on the motor like that, lining up the rail brackets with the holes in the main bracket. Okay, with the brackets lined up, we just want to add our 1/4 screws. You can see that those screw into a captive nut in each of the rail brackets. Now we're just going to snug everything down with an Allen key. All right, our final step for assembly on the Z-axis is going to be our roller system for the Y-axis, and that's the system that goes on these axles right here. And it's made up of several different components. We've got several 608 bearings, we've got a number of washers, we've got a series of these acrylic wheels, which I'll explain here in just a second, and then our back plate here, which will house the lead screw nut for our Y-axis. Okay, why am I using these 3 acrylic discs? Well, it's really simple. We needed something that would fit in the Y-axis horizontal member and slide easily but not allow any lateral movement. If you remember in our X-axis assembly, we had 2 rails to work with, so we just needed a flange to sit on one edge of the slot. In this case, we needed something to fill the entire slot without any play. There's probably easier ways to do this, but I had a bunch of acrylic on hand, so I found 3 different sizes that, when combined, were the exact width of that slot that didn't allow any play. And that's how I came up with the Y-axis roller assembly that you see here. The assembly starts with a washer, then one of our 608 2RS bearings, then a second washer. Then we've got a set of 3 acrylic wheels. A third washer. Another 608 2RS bearing. Our 4th and final washer. And then a hex nut. And that right there is essentially our wheel assembly. With all 4 wheels assembled, the final step is to check to make sure that the assembly slides onto the Y-axis horizontal member. So we'll put this on here. We want to make sure that it's a nice snug fit, which doesn't have any play in that direction, no play in that direction, and it slides cleanly on that horizontal member, which it looks like it does. As I mentioned, The last thing that we would need to add is this back plate, but we'll wait until the Y-axis assembly build to add our lead screw nut for the Y-axis before we assemble it to the gantry. All right, guys, that wraps up the Z-axis build. I hope you enjoyed. Next video, we're gonna be taking a look at the Y-axis, but in the meantime, check out my Patreon page at patreon.com/Ricky Crum for additional information on this build, as well as past videos. Thanks, guys. See you next time.